In this video we will use Gaussian elimination. Basically we will use the new notation that we learned in the previous class in order to do some standard problems at the beginning. So let's do problem 1. Solve the system x plus 2y plus 2z is equal to 9, 2x plus 4y minus 3z is equal to 1, 3x plus 6y minus 5z is equal to 0. The first thing that we want to do is create the augmented matrix, okay? So how do we do that? We just collect the coefficients and the constant at the end and put them in the matrix. So the first row gives me, the first equation gives me the first row. So I have 1 times x, 2 times y, 2 times z, and this vertical line 9, or sometimes I put it dotted vertical line, sometimes full. Second equation 2, 4 times y, negative 3 times z, 1, so this is 3. And the last equation 3 times x, 6 times y, negative 5 times z, and 0. And as we said, this corresponds to the variables x, y, and z, and this is equation 1, equation 2, and equation 3. Okay, so what did we say in the class, right? Second. So first we're trying to find the pivot position. So, and that's going to be our column. The pivot position in this case is this one right here. Okay. It is already a 1. Okay, so I don't have to do anything with the first row at this moment. I don't have to change it. It's already 1. I want to bring it into row reduced echelon form, and at this place I need to have a leading 1. So already I have 1. Okay, so what do we do then? The next step is to make the constants below this one zeros. So let's first concentrate on equation 2. What do I have to do with equation 2, with row 2, in order these two to become 1? So I'm going to change row 2, so I say row 2, 2 minus 2 times 1 is 0, right? 2 minus 2 times 1 is 0, so I'll take row 2 minus 2 times row 1, it's my new row 2. So what do I get? Because I'm just changing row 2, the first and the third row stay the same. So 1, 2, 2, 9. And the third row, 3, 6, negative 5, 0. The only thing that I've changed is the second row. So let's see. 2 minus 2 times 1 is 0. 2 minus 2 times 1 is equal to 0. 4 minus 2 times 2, 4 minus 2 times 2 is equal to, again I get 0. Negative 3 minus 2 times 2, that's negative 3 minus 4, that's equal to negative 7. Okay, and 1 minus 2 times 9, 2 times 9 is 18, 1 minus 18 is negative 17. Okay, next. As we said, because this is our leading 1, okay, all the entries below that have to be 0. Right? So now I have to take care of this 3. So I'm affecting just the third row in this step. R3 minus 3 times R1 becomes my new R3. So what do we have? 1, 2, 2, 9, 0, 0, negative 7, 17, and then 3 minus 3 times 1, right? 3 minus 3 times the first row is 0. 6 minus 3 times 2, it's also 0. Okay? And negative 5 minus 2 times 2 is equal to negative 9. Minus 3, my bad. So 5 minus 3 times 2 is negative 5, minus 6 is negative 11. And the last entry is 0 minus 3 times 9. So 0 minus 3 times 9 is negative 3 times 9, and that's negative 27. Okay? So how to proceed here? Well, there are two things that we can do. One of them is just to look at what this column here gives us, especially in the second and the third row. Okay? Or if you don't want to go there, I'm going to address that later on. So if you just, I want to, okay, so if you follow the standard, follow the standard Gaussian elimination procedure, what do we have to do? Once I have finished with the first leading one, cover the first row and figure out where your next pivot position is going to be. So the first non-zero term is negative 7, right? So I want to make that negative 7 a leading one. How to do that? I'm just going to multiply it by negative 1 over 7. R2 becomes my row 2. Okay? I don't change the first row and the third row. So 1, 2, 2, 9, 0, 0, negative 7 over negative 7 is 1. That's what we wanted. And then 17 divided by negative 1 over 7 is negative 1 over 17. And the last one here I have 0, 0, negative 11, negative 27. Now this is the leading one. In order to bring it to reduced row echelon form, I have to make this entry here a 0. Okay, how to do that? Well, I'm gonna say row 3, how to eliminate negative 11 with the one above. Well, all I have to do is row 3, which is negative 11, plus 11 times row 2 becomes my new row 3. And then what do we have? 1, 2, 2, 9, 0, 0, 1, negative 1 over 17, and then 0, 0 minus 0, 0, negative 11 plus 11 times 1 is 0, okay? And the final expression here is negative 27 plus 11 times 1 over times negative 1 over 17. Okay, so let's see how much is this. Negative 27 minus 11 over 17. Let me just make sure that I got that right. I multiply the second row by 11 and I get negative 11 over 17. Okay, so 27 times 17, 49, 4. This is 14 and 4, 189, and then here I have 27, 9. This is, how much is this? 5, 4. 400, negative 459 minus 11 over 17. I brought these under common denominator, and then I have a 0, 7, 4 over 17. So the last term is negative 470 over 17. And then what did we say in class? What did we say in class? If I have a row in the coefficient matrix full of zeros, right? And then the corresponding term in the augmented column is different than 0, then this system has no solution. This system is inconsistent. So when we say that the system is inconsistent, it's the same thing as saying it has no solution. So this system has no solutions. Okay, why? Because if I look at this is x, y, and z, right? If I look at this third row, that means that 0 times x plus 0 times y plus 0 times z is equal to negative 470 over 17, or that 0 is equal to negative 470 over 17. And this doesn't make any sense. I previously said that we could have come to the same conclusion just by looking at these two columns, at this point. Why? Because if you look at the second and the third row, we would get that negative 7z is equal to 17 and negative 11z is equal to negative 27. From here, we get that z is equal to negative 17 over 7, and that z is equal to negative 27 over 11. And what did we say? Sorry about that. What did we say about solutions in linear algebra? The solution might be one or infinitely many solutions. You cannot have two different values for z. So at this very moment, you could have concluded that this system has no solutions.